Hello everyone, welcome back to TechOps tutorial. In today's video, we will troubleshoot a common issue in Kubernetes Homelab running on VirtualBox. Sometimes pulling container image from Docker Hub or other registry becomes extremely slow even though internet connectivity appears to be working normally. In this video, you will learn how to troubleshoot slow image pull, how to verify Linux networking and routing, how VirtualBox networking affects Kubernetes, why bridge mode can cause poor performance, how switching to NAT resolve this issue. So let's get started. Here on my screen you can see, on the left side you can see the problem and on the right side you can see the solution. The existing environment is set up on VirtualBox. Let's take a SSH access of the server. I have logged into the worker node. I have a Kubernetes cluster with one master and two worker node. Each VM has two network adapters. Adapter 1 for internet connectivity, adapter 2 for host only network used for Kubernetes node to node communication. Let's verify the Redis image. Here ictl image Redis. There is a Redis image. Let's remove it. Sudo crictl rmi redis :7. There is no output now. To check the current image pull speed, I will try to pull the same Redis image. This is the command. Notice the download speed 3.9 KB per second. Currently I am getting 3.9 KB per second speed. Let's wait. I will pause the video and resume back once this is done. Anyhow, it is showing very less speed, 56 KB per second. It is pulling an image from docker.io, Redis image, and the tag is 7. I will pause the video and resume back. Now you can see 28 MB is downloaded. Now I am getting speed 100 KB per second. The size of Redis image is near about 40 MB, 40 or 41 MB. Let me pause this and resume back once this is done. I am doing a speed test. You can see I am having a 30 Mbps download and 33 Mbps upload speed. Even though on a virtual machine I am getting 96 KB per second. Now you can see we have successfully pulled the Redis image. Total time took 7 minutes 23 seconds, 41.6 MB, and the speed is 96.2 KB per second. Average download speed reported by container D is 96 KB per second. My internet speed is around 30 Mbps, so this is far slower than expected. Let's investigate. I will open another terminal. Let's run IP address. We have two interfaces, ENP0S3 and ENP0S8. ENP0S3 has this IP address 192.168.29.x. This is my internet facing adapter. And ENP0S8, it has the IP address 192.168.56.x. This is my VirtualBox host only adapter used for Kubernetes cluster communication. I already fixed the routing issue before recording this troubleshooting session. So currently my routing is correct. Let me explain what I check when troubleshooting and also show what an incorrect configuration would look like. IP route. Here you can see the default is 192.168.29.x. and the interface is ENP0S3. Earlier it was pointing to default via 192.168.56.255 device ENP0S8. Linux uses the default route whenever it does not have a more specific route to a destination. Internet traffic normally follows the default route. If the host-only adapter is configured incorrectly with a default gateway, it can lead to routing issue or unexpected behavior. Although Linux may still choose the correct route based on the route matrix, this configuration is incorrect and should be avoided. Let's verify the actual route. You can run IP route get. This is the correct. I have already fixed this. Whenever we are running IP route get 8.8.8.8, it should not point to this interface 192.168.56.255 device ENP0S8. Check IPv4 connectivity. You can ping -4. Internet connectivity is working. If this fails, image pull from Docker Hub or other registry will also fail. Check DNS resolution. DNS resolution is also working. I am forcing IPv4 using -4 option because some environments try IPv6 first. Using IPv4 gives consistent troubleshooting result. Since internet connectivity, DNS resolution and routing all looks healthy, the bottleneck is likely outside the Linux networking stack. Let's open a VirtualBox setting. Let me access VirtualBox. This is VirtualBox. Right click, go to settings, click on network. Here you can see adapter 1 is configured to a bridge adapter and the name is Wi-Fi 6 AX200. This adapter provides an internet access. This adapter connects the virtual machine directly to my physical network through the host Wi-Fi adapter. Let's click on adapter 2. This is host only adapter. Name is VirtualBox host only Ethernet adapter. This network is only used for Kubernetes communication. Host only adapter should not have a default gateway. At this point, we have verified the Linux networking stack, internet connectivity, DNS resolution, routing, and the host only adapter configuration all looks correct. Since everything inside the operating system appears healthy, the next step is to investigate the virtualization layer. In many Wi-Fi environments, VirtualBox Bridged networking can introduce poor throughput even though the basic connectivity is working normally. Let's access the terminal. Verify NetworkManager. The output shows IPv4.gateway is hyphen and IPv4 never default is yes. This configuration is already correct on my system, so it is not the cause of slow image download. However, if you find a gateway configured on the host only adapter or IPv4 never default is set to no, you can correct it using the following command. I will show you the command. You can run this. If you see the value is no, and here if there is any IP address, you can just run this, give the sudo password and recheck. You should get this output. Now let's see how to actually fix this issue. Let's power off the VM. Go to settings. Since we have ruled out Linux networking as the cause, let's change the VirtualBox networking mode and see if that improves the download speed. I have opened the VirtualBox. Right click on the machine, go to settings. You will get this window. Click on network. Now here you can change the adapter to NAT from bridge adapter to NAT. Leave adapter to unchanged. Click OK. Right click, start without GUI. NAT is generally the most reliable option for VirtualBox Homelab because VirtualBox manages the output networking instead of relying on physical Wi-Fi bridge. Let's access the terminal. After booting the VM, run IP. I need to read access. Okay. After booting the VM, run IP address. Notice the IP address has changed from my physical network to VirtualBox NAT network. That's expected when switching from bridge mode to NAT. IP route. The default route now points to NAT interface, which provides the internet access. The host-only adapter is still used for the communication between Kubernetes nodes. IP route 8.8.8. Linux confirms internet traffic is leaving through the correct interface, that is ENP0S3. Now we will pull the same image. Before, let's delete the image. Sudo crictl rmi redis :7. Give the sudo password. Now pull again. We are running this pull command with time. Now you can see I'm getting more than 1 MB per second. Now it is 2 MB. So you can see we have successfully downloaded the image. The total size of the image is 41.6 MB and we got the download speed 1.8 Mbps per second and total time took 22 seconds. Within 22 seconds, we are able to download. Your results will vary depending on your internet connection and hardware, but you should see a significant improvement compared to bridge mode. The image is now downloads at an expected speed. The only change was switching VirtualBox from bridge to NAT. Today we have learned that slow Kubernetes image pull are not always caused by Kubernetes or container D. In this case, Linux routing, DNS and internet connectivity were all working correctly. The real bottleneck was the VirtualBox networking mode. After switching adapter 1 from bridge to NAT, image download performance turned to normal. Whenever you are troubleshooting slow image pull, check internet connectivity, DNS resolution, Linux routing, container runtime logs, and VirtualBox network configuration. For most VirtualBox Kubernetes Homelab, I recommend using NAT for internet access and host-only networking for communicating between networking nodes. Thanks for watching and I will see you in the next one.